Hi guys, this is Ryan here from More Place More. No, it's a joke, he made me do it. So to combat aging, we decided to look at the preventative means. And in that case, we want to look at preventative means in identifying biomarkers. And in this case, we're using service animals, more specifically, dogs. And dogs have a very keen sense of smell. Next slide, please. Okay, so why dogs? Man's best friend, of course. No, dogs actually have about 300 million olfactory receptors in their nose. Compare that to humans who only have about 6 million total. So dogs are also very easily to train in comparison to other animals like cats and so forth. So we can use current day means of positive reinforcement and other type of reinforcement techniques to indicate whether or not a biomarker is present. So currently dogs are able to identify multitudes of cancers, diabetes, for blood glucose level, hepatitis, all these seizures, all from being able to smell either your breath, saliva, urine, feces, sweat. So all these means are non-invasive. So why are we using dogs in this way? Reason why we are using dogs is because if we are able to identify the specific biomarker in which a disease is present, we can hopefully create a type of bank, a sort of biomarker bank in which diseases can be, biomarkers can be listed. And then from there, we can create stuff like analyse kits, which are used to test for certain biomarkers. So using a data sheet that we got for COVID-19, we are able to analyze, we're able to run that through Python and able to analyze the effectivity of that, of dogs compared to the PCR test, pardon me. And from that data, we realized that dogs are about 99% effective by identifying diseases, and the PCR being our gold standard of IDing it. So, based off that, we can extrapolate it to possible other diseases. So we use a model to see that how effective a dog is, and from there, hopefully we're able to identify a certain biomarker in which we can load up into a bank of some sort, in which we can then hopefully make open source for other industries to reduce the prices of analyse kits. Now, we do have some ethical issues when it comes to this, because training dogs is taking a toll on them. So ethically, what we can do is have a sort of retirement system like current dogs have for military dogs. So after a certain amount of time, we service them out, and hopefully they have a better life after, so we don't have the ethical concern of that. And this is my team. Big thanks to Deepak when it came to the mathematical research, or mathematical analysis. Our head of our project right here, Michael. Dilara, in addition to head, and both ladies, Olivia and Keren, when it came to creating this beautiful PowerPoint that we have. And thank you for all the mentors that gave us insight on our project on how well it would be. Thank you.
What do you hope the ultimate costs would be? I would imagine nowadays PCR tests are pretty inexpensive.
So yes, they're inexpensive once you get them going, but as you're training a dog, over the long period of time, once you get the dog trained to it, ends up being cheaper than first developing that first PCR test. And then if you compare that to analyse kits, those analyse kits run for like $3,000 or $4,000 when it comes to cancer biopsies. So they're much more expensive.
Do you imagine these dogs being residents in a clinic, and when people come through?
Yeah, it makes it easier for them to be non-invasive, so that way a dog can run through more people than, say, a machine could. And obviously it's less invasive. You don't have to draw blood from the person, you just have the dog smell them. As long as we know the dog is capable of IDing it to a certain percentile.
I have just an addition on that. Dogs are more effective than PCR in the case that dog can predict in pre-hand. Like if you have a symptoms, then you can go to the PCR test, right? But dog can alert you before having some kind of sense that you feel yourself. Dog can sense that. That's how in all these kinds of disease, dogs are more effective on.
And here's a wild card. What do you think about a dog with a Neuralink?
Ooh.
Did anybody bring that up before?
No, that's the first time we're hearing about that.
Oh, that was a surprise. That's interesting.
I'll be honest, I don't understand exactly how Neuralink works, so I can't give a reasonable take on it. I'd have to do more into it to be able to come back with an answer for that one, honestly. Yeah.
Thank you.
Any other questions? Perfect. Thank you.